Hi friends, my name is Alexander. Thank you for joining me today for the Briseman Literacy Course on Crypto Level 1. Our goal is to bring you to know a little bit about what the blockchain is, what is DeFi, the security and good habits you should have, how to purchase crypto, what are NFTs, how to get an NFT, staking, the common tools of decentralized finance, and basically, everything you need to know from getting in to getting out. So this is really, of course, not financial advice. Everything you hear should always be cross-verified. We're well-intentioned here, but always do verify the information that you get. Doing your own research is always the best way to go. So let's get going. So this might sound a little bit technical at first. Don't worry, we'll get through it. It's not that bad. So how does a blockchain work? Well, many things need to be considered to describe a blockchain. You need the blockchain platform, you need nodes, there's transactions that make up blocks, security implementations, the process of adding new blocks to the chain. The blockchain architecture is something that is undoubtedly complex. With blocks being connected with each other through their respective hash codes, the whole blockchain ecosystem becomes a Fort Knox technically. Whenever a blockchain transaction is a flag is raised, a blockchain consensus needs to be achieved to update the same in the blockchain. So whenever you do a transaction, that transactions needs to be validated before it's added back to the blockchain. Instead of relying on a third party to mediate transaction, member nodes in the blockchain network stick to a blockchain consensus protocol to agree on the ledger content and the cryptographic hashes and digital signatures to ensure the integrity of the transactions. Once authenticated, these blockchain transactions are considered successful and are irreversible. Transactions rely on a lot of hash values and hash functions. These hash functions are mathematical processes that input data of any size, perform required operations on it, and return the output data of a fixed size. These functions can be used to take a string of any length and input and return a sequence of letters of a fixed length. The functionality of hash function makes them apt for transaction processing. Regardless of the size of the transaction, the final output will always be fixed and untempered. This is truly the real strength of the blockchain, is that you don't need any third party to verify it. The transaction is done within the system itself. So, and that's why once the transaction is confirmed, it's irreversible because it is integrated into the blockchain. All right. So, how does it work? Well, you request a transaction. When that request for a transaction represents a block which is created, the block is sent to every node in the network. The node validates the transactions. The nodes receive a reward for the proof of the work that they've done. And the block is added to the existing blockchain and the transaction is complete. Now, this proof of consensus method, there are many different things. So let's establish what it is. The set of rules by which a blockchain network operates and validates the information of blocks is known as consensus. A popular consensus mechanism for blockchains, proof of work, is a requirement through which expensive computations, also called mining, can be performed in order to facilitate transactions on the blockchain. Although it might be hard for nodes to generate a valid block, it is quite easy for the network to validate the block's authenticity. This is achieved through hash functions. Since hashes are quite sensitive to changes, and even minute modifications will result in a completely different hash output, they can be used to validate and secure blocks. For a block to be confirmed as valid, miners are required to generate 2 hashes, a hash of the transaction in the block, and one proving that they have expended the energy required to generate the block by solving a special cryptographic puzzle with a preset level of difficulty. The difficulty of solving the puzzle can be automatically adjusted in proof-of-work system to create a consistent time period for blocks. They are to be added to the blockchain. In summary, a miner creates a block of valid transactions. Further, the miner runs a proof-of-work algorithm to find a valid hash. When a valid block is generated, the block is added to the blockchain and the miner receives network fees and a newly created cryptocurrency. So this is why this is one of the most expensive systems that you have in terms of energy, and because there's a lot of computational work to do. There are different solutions that have been brought up, right? So different consensus mechanisms have been devised. One of them that the bigger blockchain uses is proof of authority consensus, which enables the network to reach 100,000 transactions per second. This consensus mechanism, where a validator's identity performs the role of stake instead of proof of stake, which uses monetary incentives, enables the lowest possible gas fees. The Binance Smart Chain for Recurrence is a proof of staked authority consensus distributed ledger with a system of 21 validators that has a longer block time and higher gas fees. So really the way that the consensus mechanism is devised and used is going to affect both the speed of the blockchain and the operating fees, so the gas fees that that is going to be used to do the computational work for the transactions. So this is why in occurrence the bigger blockchain is very competitive, because of the mechanism that they use is both fast and does not require as many monetary incentives as other blockchains. So now that we have a blockchain, we need to be able to see what's happening on it, and one of the tools that is available is a blockchain explorer. All right, so what is a blockchain explorer? You can see there are different ones like Etherscan, BSCScan, Briseman, and they will give you access to the blockchain data. All right, this data includes transaction data, wallet addresses, smart contracts, and much more. Is Etherscan a wallet? No, it's not. The Blockchain Explorer keeps track of what's happening on there, but it doesn't interact with it. It's not doing the transactions. It's just really a book where you can see what's happening. Right? So you can explore the different wallet addresses, you can look up the smart contracts, you can view the crypto assets that are associated to a wallet address, you can observe the transactions taking place. Really, it's going to be your reference for everything that's going to be happening on the blockchain. You're going to look at the Block Explorer. Right, and we're going to go look at it now. And you know, it's really easy how it works. Let's go see a blockchain explorer. So you have every different blockchain. Polygon has Polygon Scan, Brise has Brise Scan, Ethereum has Etherscan, and so on and so forth. So you can really see everything that's happening on there, the latest transactions. So I can see the transaction hash, and I can see that it went from this wallet to this wallet. So what happened there? Let's go see. So this wallet here has 5.849 BNB in it, and it has 16 different tokens. So, and we'll see a little bit later, right? There's a bunch of different tokens that this person didn't buy. And in security, we'll talk about what that means. So this wallet, so that's it. He just has the BNB in it. He did a bunch of transactions today. He's transacting a lot, sending out a lot of, oh, it's just a relay. All right, but that's it. So you can see all the different things that are happening on the blockchain. See, like here, I can see what the TXN was, what from this wallet to that wallet, so I can see what's in this wallet here. He got in one day, 3 hours ago. He deposited some. He went on PancakeSwap. So you can really see everything that happens is public and validated and can be seen. So this is very important. We'll get into it later in terms of security, in terms of also when you do your own research, when you're going to do your due diligence on a project, for example. This is going to be very much your best friend. So that's it for today. We have completed just the introduction to what is a blockchain. Next time we are going to do getting a wallet, setting up security, and the do's and don'ts of crypto. Because there are a lot of do's and don'ts. It's a wonderful world because it is not very regulated. You can do a lot of things within crypto with a lot of liberty, both for people that want to launch projects and people that want to invest. However, the downside to that is that there is not a lot of security in terms of getting scams, and the police is not going to help you. So you really need to have good practices and be aware of what you are doing, because as we saw, transactions are final. So once, if I sent whatever token to the wrong wallet, once it is sent, once the transaction is integrated into the block, there is nothing I can do to recover it. So it is very important. The next lesson, I want you guys to tune in and pay attention. This is something that comes back very, very often. So thank you very much. I want you guys to have a great day and have some great investments.